Hello everybody. Well, I just recorded a review which took me 30 minutes, so I figured out that probably will be too much, so I'm doing another version which I promise will be under 15 minutes. So real quick, let's talk about Monopoly and let's make it as concise as possible. So Monopoly is not a game here, right? Monopoly is a company that controls the entire market where we're dealing with a good which has no close substitutes. And that means that the company is going to deal with the demand curve for the entire market, which is a downward sloping curve as usual, right? So demand curve tells us what price we can charge and what marginal benefit consumers are getting from it. Okay, so next thing, real quick, marginal revenue. What's going on with marginal revenue in this case? We're gonna need marginal revenue because we're gonna figure out how to set profit maximizing level of output, and basically it's the same rule we saw earlier. This is where marginal revenue meets marginal cost. So we need to know how to get marginal revenue. Simply put, marginal revenue is for a linear demand curve. If you have a linear demand curve, right, like here, then you can get your marginal revenue curve as another straight line, which is twice as steep as your demand curve. Simply put, if you have your demand curve, you can get your marginal revenue curve by taking this distance, splitting it in half, getting this point, and then drawing a line that goes from the upper corner to this midpoint, and that's your marginal revenue. As simple as that. What else can we say about marginal revenue? Well, we can say a lot of things, but I think at this point we'll just stop here for marginal revenue. So now you know how to draw it if you need to. So let's not go into too many details. Okay, so let's jump to profit maximization right away. To do that, we are going to draw two graphs. One graph, as before, will show us total revenue and total cost, because that's how you can get total profit, total revenue minus total cost, right? And on the lower graph, we're going to draw some marginal variables, which are basically marginal revenue, marginal cost. So I told you earlier that this good old rule, marginal revenue equals marginal cost, is going to apply here as well. So that will give us maximum profit. So let's see why it's the case. Let's draw total cost and total revenue. So total revenue is a bell-shaped curve, but we're only showing that left half of it. Given this total revenue and total cost curve, you can see your profit just like a distance between those two curves. So of course, it will only be positive between these 2 points. So if you set your Q here, that will be your profit, but clearly it's not the largest one, right? So what if we make more? Okay, at Q2 we will make more money in terms of profit, and we will make the largest profit, as I can see. Maybe here. In fact, let me apply that rule. Basically, this rule is telling us what? It's telling, remember, marginal revenue is the slope of total revenue curve. Marginal cost is the slope of total cost curve. So one way to get the maximum profit or figure out where it is to see where the slopes. Oh, I think I got it, more or less. So the largest distance between these two curves is going to be at the point where the slopes of these two curves exactly match. which can be shown on the lower diagram by pretty much drawing marginal revenue curve and then marginal cost curve, and getting the point where they intersect, because this is where MR meets MC, or in other words, this is where the slope of total revenue curve, which is marginal revenue, meets the slope of marginal cost curve. So why that's the case? What's the meaning of this marginal revenue equals marginal cost thing? And just on its own, it doesn't really mean much, but it means, in fact, a lot, given that marginal revenue is dropping, right? This is marginal revenue is dropping, which means the slope of this curve is leveling out, so it's getting smaller. And the slope of this curve is picking up. So what it means that as you keep going like further right, increasing your output, right, with each additional unit, you're actually sending your total revenue higher up than your total cost is going up, right? I mean, both curves are growing, but total revenue is growing faster in the beginning than marginal cost, and that's basically it. If your total revenue is growing faster than your total cost, it means with Q, it means you want to keep pushing your Q, right? Because for each additional unit, you will go higher up with total revenue, then your cost will go up. So the difference between those two variables, in fact, will get larger. So as long as MR exceeds MC, those curves are spreading away, and that's what you want, right? So, and that's why you want to keep adding units to your output. So on this diagram, it means you want to keep adding units to your output as long as marginal revenue exceeds marginal cost. So in other words, all the way up to this point. Okay. On this curve, it means you want to keep adding units as long as, again, total revenue curve is growing faster than your total cost curve. So when you get exactly to the point where the slopes evened out, right? So when marginal cost kind of caught up, you see, as it was growing, it caught up eventually with marginal revenue. And this is where we want to stop, because if you keep pushing any further, as MC caught up with marginal revenue, right? Any additional unit, marginal cost actually will be larger than marginal revenue from now on, right? And that's why you don't want to go there. So you want to stop right before marginal cost is about to overcome your marginal revenue, and that will give you the largest possible profit in this situation. Okay, so that's the meaning of this rule. Marginal revenue equals marginal cost gives you the largest possible profit. So now let's draw another diagram, and this is where we're going to use this MC and MR curve, and also the demand curve, marginal revenue curve, and average total cost curve. So let's draw demand curve. Then you guys should know how to draw marginal revenue curve. It's just you pick the midpoint somewhere 1, 2, 3, 4, 5, 6 and a half. So that probably the midpoint will be 6 and a half. So divided by 2. I would say this is the way it's supposed to look. So marginal revenue. This is our demand curve, which again tells us what price is and marginal benefit is. And then we need ATC, and then we need marginal cost, MC. All right, so now we're ready to figure out where the profit maximizing level of output is, and we're ready to find our largest possible profit in this situation. So we know that this rule should give us the largest possible profit. But we need to set the level of output according to this rule. So the way we do it, you pick the point where MC intersects MR, right? Then you go through this point, and that tells you where your profit maximizing level of output is, OQ, where MR meets MC. Then as you hit your demand curve going up, you're getting your price. That's the largest price you can charge if you want to sell this quantity. And then as you're going up along this vertical thin line, you also can get your ATC. We need ATC because on this kind of graphs, it's convenient to calculate profit as P minus ATC times Q. That's profit. Remember, this formula only works when Q is not 0. Okay, so this is price. This is ATC. So this distance is P minus ATC. This distance is Q. So the whole area, the whole box is just telling us what profit is when you're producing at this level of output. Here we are. We figure out Q, we figure out profit. Finally, let's talk about efficiency. Would the monopoly bring us to the point of allocative efficiency? Well, to answer this question, we need to find the point of allocative efficiency. And remember, the point of allocative efficiency is when we are making sure that marginal benefit meets marginal cost. So it's not marginal revenue that is matching marginal cost, but marginal benefit. Okay, so technically it's fairly straightforward, right? You just see where your marginal cost intersects your demand curve, because demand curve is also your marginal benefit curve. So that's the point, and I really don't want it to match this point. Seems like accidentally these 2 points matched, but they are not. So, well, not exactly, which is a good thing, because it's just pure accident that this point matches, almost kind of match this point. It's, they're not related. Anyway, so they are not exactly the same, which is a good thing. So now we have what this is the point of allocative efficiency, because this is where MB meets MC. In other words, that's the point where level of output, where we are producing all units for which marginal benefit justifies marginal cost. Okay. And the thing is that, well, these 2 quantities are not the same. And clearly the monopoly is producing less than is efficient. And that results in deadweight loss. Deadweight loss from underproduction. That's what we're gonna see here. And to remind you how to find deadweight loss, let's recall this picture. If this is your MC, this is your MB. If you're exactly at the point of allocative efficiency, then there is no deadweight loss, and you're actually maximizing your total surplus as this area. This is your total surplus, right? But if for whatever reason we're producing less than what is efficient, let's say this quantity, then we will fail to capture the entire area of total surplus. So we will not be producing this quantity, right? These units are not being produced, well, by definition. And that means we're actually losing this total surplus. Well, we still have this area, right? Which is good, but we are not getting this. So it's deadweight loss. So if we apply same logic here, we just need to see where MC is, MB is, right? And then carefully go between these two curves from the point of allocative efficiency to the left until we hit the level of output where monopoly is going to be, because it wants to maximize its profit, not overall total surplus. So this is our deadweight loss, and the last thing we want to know is how to find its area. Well, simply put, it's this side, right, times, or actually its height times its width divided by 2. So in this particular case, basically its height is what? Is the distance between price and the point where marginal revenue and marginal cost meet. That would be this, so that will be this distance times basically this distance divided by 2. Don't forget to divide by 2. Alright, I hope you can deal with that kind of math. So calculating areas of triangles is not really that complicated. So, well, I said I would be done in 15 minutes. I'm done in 16 minutes 52 seconds. So I hope you guys had fun listening to this. I hope it helped. So I'll talk to you next time.